In this video, we are going to discuss about nucleophiles. What are the nucleophiles? Nucleophiles are electron-rich species. These are also electron donors, and these are electron-eating groups. And these nucleophiles are also called as what? Lewis bases, because these are ready to donate a pair of electrons. So therefore, these are called as what? Lewis bases. Generally, nucleophile attack at the low electron density site or positive centers, because these nucleus are electron rich species. So therefore, they always attack at that what? Positive centers or low electron density site. So now for suppose this molecule we are taking. Now at this carbon there is a positive center is there. That means this carbon is electron deficient. This position is electron deficient position. So therefore, this nucleophile is electron rich. So therefore, it is attacking at this electron deficient site. Then we are going to get this molecule. Same way when we are taking these alkenes. Now this is having minus charge. This carbon is having positive charge. Now this carbon is the electron deficient center. So therefore, the nucleophile is always attacking at that what? An electron deficient center. Nucleophiles attack at low electron density site or positive centers, because these are electron rich species. Now these nucleophiles are classified into three types. One is called as what? Charged nucleophile, neutral nucleophile, ambident nucleophile. What is a charged nucleophiles? All negatively charged species are nucleophiles. All negatively charged species are nucleophiles. For example, H minus, hydride, OH minus, OR minus, CH3 minus, halogens, fluorine, chlorine, bromine. Next, carboxylate ion, NH2 minus. All negatively charged species are and nucleophiles. Here, negative charge is nothing but what? 2 electrons. This is nothing but what? 2 electrons. Now this is nothing but what? 2 electrons. Okay, now. So now for suppose when we are taking this cyanide. Now this is C double bond O group. This is a nucleophile. All negatively charged species are nucleophile. No? Carbon, oxygen, which is more electronegative. Oxygen is the more electronegative. So carbon will get the positive charge, because oxygen is the more electronegative. Now this carbon is electron deficient center. So therefore, nucleophile is attacking at an electron deficient site. Okay, then what we are going to get? We are going to get CO minus. Then we are going to get that what? Cyanide. Okay, this is all charged nucleophiles are negatively charged or nucleophiles. Next one is neutral nucleophiles. The covalent compounds. In covalent compounds, central atom is having 8 electrons with at least one lone pair is present, means they are called as what? Neutral nucleophiles. So now when we are taking ammonia, now this is the structure of ammonia. Now this is a covalent compound, because non-metals are present. Between the non-metals, covalent bond is present. Now nitrogen is containing how many valence electrons? Nitrogen containing 5 valence electrons. Now hydrogen containing 1 valence electron. To get the stability, hydrogen sharing 1 electron from that what? Nitrogen. To get stability, nitrogen share 1 electron from each hydrogen. So therefore, what we are going to get? We are going to get now N, H, H, 1 lone pair. See now around nitrogen 3 bond pairs, 1 lone pair is present. So therefore, total number of electrons. Each bond means how many electrons? 2. 1, 2, 3, 4, 5, 6, 7, 8. Follows Lewis octet rule and containing one lone pair. Then these are called as what? Neutral nucleophiles. Ammonia is containing one lone pair, so therefore it is a nucleophile. Next, amines, primary amines, secondary amines, tertiary amines, hydrogen, nitrogen family, that is phosphine, phosphorus trichloride, all are containing one lone pair. Central atom is containing one lone pair means then they are acting as what? Neutral nucleophiles. See now, this is water molecule, oxygen containing two lone pairs. Alcohol molecule, oxygen containing two lone pairs. Ether, ROR, two lone pairs. Next, oxygen family, hydrogen sulfide, thiol, thioether, sulfur containing two lone pairs. So neutral nucleophiles means if the central atom is containing at least one lone pair is there means then they are called as what? Neutral nucleophiles. Water and alcohols are the neutral nucleophiles. Next, organic compounds containing carbon-carbon multiple bonds. They also behave as what? Neutral nucleophiles. Organic compound containing carbon-carbon double bond, carbon-carbon triple bond. Then they are also acting as what? Nucleophiles. For example, alkenes. Alkenes means carbon-carbon double bond is present. So therefore they are acting as what? A nucleophile. Alkynes, carbon-carbon triple bond is present. They act as what? Nucleophiles. Benzene derivatives. Benzene, toluene, phenol, aniline. All these are acting as what? Nucleophiles. Carbon-carbon double bond or triple bond is present. They are called as what? Nucleophiles. Because of the presence of loosely pi bonded pi electrons, they are acting as what? Nucleophiles. Next, organometallic compounds. Best example is called as what? A Grignard reagent. In Grignard reagent, this alkyl group is acting as a what? A nucleophile. For example, see now we are taking that what? Ethyl magnesium bromide. This ethyl group is acting as a what? A nucleophile. Next, in Franklin reagent, R2Zn. This alkyl group is acting as a what? A nucleophile. Next, Gilmanan reagent. The alkyl group is acting as a what? A nucleophile. Okay. Next one is ambident nucleophiles. What is ambident nucleophiles? The species is having two nucleophilic centers, but only one is capable of donating a lone pair of electrons. Is called as a what? An ambident nucleophiles. In this ambident nucleophiles, one nucleophilic center is neutral, other one is charged. For example, we are taking that what? Cyanide. See now this center is neutral center. This is called as what? Charged one. Now in cyanide, either carbon can donate or nitrogen can donate. So therefore it is having two donor sites. But only one is capable of donating that what? Electrons during the attacking. Okay, now for example, now alkyl halides. Alkyl halides, whenever they are reacting with cyanide, then what we are going to get? We are going to get RCN plus X minus. Same way this alkyl halides reacting with cyanide, then we are going to get RNC plus X minus. That means from these two what we are understanding here means here carbon is donating the electrons to this alkyl group, because this alkyl group is called as what? Carbon halogen. Halogen is the electronegative, this carbon is electropositive, the electron deficient center. So therefore this nucleophile is donating the electrons to this low electron density site. Here this cyanide is the ambident nucleophile. That means either carbon can donate the electrons or nitrogen can donate the electrons. Here carbon can donate the electrons to alkyl group. In the case of this KCN or NaCN, then we are going to get that what cyanides. But whereas in the case of this one, for suppose when we are taking that what a covalent compounds like AgCN, then what will be happening here? Nitrogen is giving the electrons to this alkyl group, because this alkyl group is an electron deficient center. So therefore, the nucleophile is donating the electrons to this electron deficient center. Already we studied nucleophiles attacking at low electron density site. This is low electron density site. This is electron rich, electron deficient. So then here nitrogen is donating the electrons, so therefore we are going to get isocyanates. Here carbon is donating, so therefore we are getting that what? And cyanides. From this example, what we are understanding is here either carbon can donate the electrons or nitrogen can donate the electrons. But both are not at a time, they can't donate the electrons. So they are called as a what? Ambident nucleophiles. They are having two donor sites. This is donor site, this is donor site. But one is capable of donating the electrons. Okay. Next one is this one. Next this one. NO2 minus. SCN minus. Okay. Here nitrogen can donate electrons, oxygen can donate the electrons. Two donor sites. Two donor sites. Nitrogen can donate, oxygen can donate. Sulfur can donate, nitrogen can donate. Two donor sites, but only one is capable of donating the electrons. Next, this is overall information about that what? A nucleophiles.